This is lesson 8.4, solving with square roots, and this is a little bit different than your notes, so I'll explain through this one, but the examples are the same. Solving with square roots. So we're going to talk about solving equations, and we've done solved many types of equations in the past. But we're going to focus on this type of equation because of its necessity for later on. Solving with square roots. Well, first of all, we have to understand what is a square root. That's one of two equal factors that says if a squared equals b, then a is the square root of b. Now, a more specific example is that if I ask you to give me the square root of 144, in other words, I'm asking this: what squared gives me 144? Then you would say 12, because 12 times 12 is 144, and negative 12. Negative 12 times negative 12 is also 144. So what we're doing is, when we have an equation with a square in it and it's by itself, the process of solving it would be to undo the square by square rooting. So the square and the root cancel, and you're left with the square root of 144. However, because we just stated 12 and negative 12 when squared is 144, we have to write both of them down. Now there's a couple of shortcuts to this, and that is to write plus minus 12, and that represents two answers. And that's where this notation comes from. So how do you solve these equations? Now again, the most important thing to remember is this piece. There's two possible answers when you're dealing with solving square roots, or equations with square roots. The same rules apply. If you're going to undo a root, or a square, you must first isolate it. So I would first divide by 4. So I would isolate it, and then I would get x squared equals 25. Now I can go ahead and undo the square by square rooting. You're left with x equals, the square root of 25 is 5, but it is plus minus because 5 squared equals 25, and negative 5 in parentheses, big difference, is also 25. Now keep in mind, if you went negative 5 squared, you would get negative 25, because the calculator that you're using does not understand that negative 5 should be squared with it. So the parentheses make a big difference, and this is not what we're talking about. So two possible answers, plus minus 5. Now let's also clarify one thing. If I ask you to give me the square root of 25 and write it that way and ask it that way, the answer is 5 and only 5. That is different than saying what squared gives me 25. These are two different types of questions. The square root of any number is always a positive number. But if I have an equation written in this form, then we must accept the fact that there are two possible answers. And we could prove that by plugging them back in. So we are working with these types of questions today. So let's look at the next one. Now this is pretty complex compared to the other, but again, it is important to understand that we cannot undo a square unless we have it isolated. So our same rules apply in terms of isolating that piece. We would subtract 3, and we would get 0.5x squared equals 8. Divide by 0.5, and we will get x squared equals 16, because 8 divided by 0.5 is 16. Now we can go ahead and undo the square, and we will get x equals, the square root of 16 is 4, but because it's written in this form, there's two possible answers. Next one, same idea. Isolate the square first, divide by 2, undo the square. In this particular case, what squared gives you 0? There's only one answer. Plus minus 0 doesn't make any difference, it's still 0. So in this particular case, there's only one answer and it's 0 because there is no plus. There's no difference between a plus 0 and a minus 0. Alright, even more complex. Again, we have a power, but look what we have in the parentheses. Something more complex than before. And we'll show you how to get to that in a moment. First of all, we want to isolate the parentheses with the square. Again, we have to isolate that parentheses with the square, so I have to get rid of the 5 by division. Alright, now I'm not going to add 4 yet because that's inside the parentheses and I can't get to that yet. So I need to undo the square first so that I can actually get to the minus 4. That will give us x minus 4 equals, now again, a plus minus 3. Now again, I'm undoing the square, so the x minus 4 is protected by the square, so when I square root, the square root and the square cancel each other out, leaving us with whatever was in the inside of the parentheses. Because it's something, the equation says something squared equals 9, I have to respect that and say the answer will be a plus or minus 3 when I root it. Now this puts us in a different place than before, because now when I isolate and solve for x in this case, I would add 4. But on the right side I have something unusual. I have added 4, but now I'm going to add and subtract 3. Now that means two possibilities can occur. First of all, we have this problem, 4 plus 3, and then we have 4 minus 3, because indeed they are two different operations. So we must respect each one. So in one particular case, if it was a positive 3, our answer would be 7. If it was a negative 3, we would get 1. And both of these are considered solutions. So two solutions in this case, and they are not the same number, unlike the other ones where it was just a plus minus 3 or a plus minus 4 and whatnot. Next question, same scenario. Subtract 41. Again, look to the left, there's nothing there, so it's positive. We would undo it by subtraction. And that would be 36. We have a negative in front, so again I cannot quite get to that yet. That's a negative, by the way, sorry, negative 36. So I have to divide by negative 1, and that will give us x plus 6 squared, and that would give us a positive 36. Now we can get rid of the square by square rooting. That will give us x plus 6 equals a plus minus 6. Now we're going to subtract the 6 to finish the problem, and we get x equals minus 6, because I just subtracted 6, and then plus minus 6. Now notice I put the plus minus piece second in both of these examples just to kind of keep it hopefully a little bit more clear. Now again, because of the plus minus, we have two possibilities. We have x equals a negative 6 plus 6, and we have x equals a negative 6 minus 6. If you choose positive 6, you'll get 0 for a solution. If you choose negative 6, you get negative 12. Two possible solutions again. Now I'll make one observation here for you, and that is that if I ever have something squared equals a negative number, even though I can root 9, this is not a real solution, and we will not be able to do this at this point. Okay, so I think pretty much all our examples will have something squared equals a positive number. Alright, and this ends lesson 8.4.